Many metal framing methods are employed today. Light gauge steel construction is often referred to or called steel for stick construction, since each wood framing member in a typical wood framed home assembly is replaced with a metal framing member. Another metal framing method, similar to light gauge and steel construction, involves the use of heavier gauge and light gauge steel studs. The heavier gauge studs are placed 4 foot on center, with the lighter gauge members installed between the studs. Here are some different profiles of different types of metal framing members, and light gauge steel framing members are available in various shapes, thicknesses, and strengths. Common light gauge steel framing members include the C-shape, track, U-channel, and furring channel, as they are there in the picture on the right from top to bottom. The C-shape is the most common shape produced for light gauge steel framing and is used for studs and joists. C-shaped members consist of a web, flange, and a lip. Web depths range from 1 inch and 5/8 for 1 inch and 5/8 thick wall studs to 12 inches. The flanges stiffen the web and provide surfaces for attaching sheathing and gypsum board. The lips extend from the flanges on the open side and stiffen the flanges. The term gauge traditionally has been the unit of measure for identifying sheet steel thicknesses. The higher the gauge number, the thinner the steel. Steel thicknesses also have traditionally been given on prints as mils. A mil is equal to 1/1000th of an inch. Metric dimensions in millimeters are increasingly being used to express steel thickness. 1 millimeter is equal to 0.001 of a meter. The table in figure 45-3 provides gauge dimensions and their decimal, inch, mil, and SI metric equivalents. When using the right STUF system stuff, the web depth and flange width are expressed in hundredths of an inch. For example, the web depth for a stud with a 6-inch depth is expressed as 600, or 6 inches equals 1/100th times that amount to equals 600. The flange width for a stud with a 1 5/8 flange is expressed as 162. That's 1 5/8, which equals 1.625 inches of an inch. And of course, you take the 1.62 times it by 100, and it equals 162. That's where they come up with a 162 number. So the steel thickness of a light gauge steel framing member is the thickness of the base metal in mils before being galvanized. Self-tapping screws are used to fasten metal members to each other and to fasten other materials to framing members. As the name implies, self-tapping screws cut their own threads as they are being driven into the metal framing members. Self-tapping screws include self-tapping and self-piercing screws. The self-piercing type actually don't tap the same as the self-drilling, just to say. So a variety of screw head types are available for different operations. See this figure here on 45.6, the various different types. You have screws with pan heads, hex washer, or pancake heads, which are recommended for fastening steel to steel. The main thing is that there are a few common types that are predominantly in use, and some of these are lesser found. It depends, though. If the gauge of the metal is a thicker type metal, a lower gauge, then sometimes you have to use some different types of screws. So here's a chart of the metal type framing fasteners and their different usages, their different operations. You can see here the most common used one is the number 8 type screw. That's just it's really the diameter and the thickness of the thread. Of course, number 10s are even thicker, and number 12 is, the more you go up in the number, the thicker the thread. So you can see here that by looking at the chart, the number 6 is used sometimes though in steel to steel type operations, or for all types of bearing and load bearing and different items, but most predominantly used overall is the number 8. So drive pins, they're made of high-treated, high-carbon steel that produces a very hard fastener. And drive pins have spiral grooves or knurls on the shanks to draw the pins tight when driven. As the pin is driven, the point penetrates the sheathing and bores through the steel. This action pushes the steel outward away from the pin. The steel then compresses and grips the pin. And welding can be used to prefabricate wall sections as well. Most often wall sections are welded in a shop rather than on the job site. Welding must be performed by certified welders and according to the American Iron and Steel Institute specifications, AISI. Spot clinching is a method for joining two metal framing members and provides a strong connection without the use of mechanical fasteners. In the spot clinching process, a pneumatic clincher is used to press a section of one framing member into the adjoining member, leaving a button or stitch indentation. Spot clinching is currently approved by the International Code of Building Officials, but has yet to be approved by other code organizations. A drywall screwdriver is often used to fasten metal framing members together and to fasten panel sheathing or gypsum board to metal framing members. The nose piece on the drywall screwdriver controls the depth to which the screw is driven and prevents screws from going through the panel or gypsum board. Pneumatic steel framing tools or pin guns are used to install drive pins. Pneumatic steel framing tools operate on air pressure ranging from 90 to 120 psi. The pressure required to install drive pins depends on the steel thickness. Pneumatic steel framing tools have a safety contact to prevent the gun from firing unless the trigger is pressed and the tool is firmly pressed against a work surface. An overdrive control mechanism prevents overdriving of the pins. In addition, the air compressor line pressure must be adjusted to the proper setting for the steel to be fastened. Too low pressure will result in pin failure. A drive pin should be driven so its head is flush with the panel surface. As you see here on the far left, that's good. Overdriven, too deep below the surface, weakens the bond, and underdriven has the same effect as well, weakening the bond. It also leaves an amount exposed that can just simply get in the way of other items. So an abrasive cutoff saw or a chop saw is a power tool used to cut metal framing members. Unlike power miter saws, abrasive cutoff saw blades cannot be rotated from side to side for angle cuts. Rather, the saw fence is adjusted from side to side for angle cuts. An abrasive cutoff saw is equipped with an abrasive blade. These are for the heavier gauge steel studs, the commercial type, the type that they're often they're too heavy of a gauge to be able to be cut, even with hand snips. But there are other alternatives. So here's one of those alternatives. These are handheld power shears, and they can cut up to metal generally up to about 68 mils. So another type of idea, the plasma arc cutting, is an electric arc cutting process in which metal is cut by melting a portion of the metal and blowing the molten metal away with a stream of heated, high-velocity ionized gas. Plasma cutting is used when a large number of metal framing members must be cut, and usually done on, we could say, on a CNC type idea in a factory. That's for prefabrication methods. Here's another item used as a common tool, the locking C-clamps, and it secures the metal framing members tightly together while they're being fastened. This is so the metal can be a little bit slippery there when sitting in the C-channel track, especially studs. When you're driving a screw between the track and the stud, it's a lot easier to put a C-clamp on, hold it tight, it doesn't get away, it doesn't move to the left or right, not a bit. It's also safer because when you do slip with a screw and screw gun, it's pretty easy to get a little bit of hand damage, or and obviously even when working on ladders, you could actually fall off the ladder just by the amount of force you're putting there to drive that screw is pretty significant. So load-bearing C-shaped steel joists are available in sizes comparable to wood joists and range from 2x6s to 2x14s. So the idea is the metal studs framing is pretty much lockstep in behind what wood framing is doing as far as for sizes and everything like that. You notice in that first size, 1 5/8, that would be the size. Let's say there was a 1x2 that you're using for some reason. Well, the actual size of a 1x2 is not 2 inches on that dimension. It's 1 5/8. The idea for mirroring all these type of dimensions is to keep everything the same as wood construction. So joist thicknesses and sizes are determined by the live and dead loads, and the floor must support, of course, in its unsupported span. Same as the wood, where there are span tables and charts for figuring the allowable spans. Openings are provided in the webs for utilities, such as electrical wiring or plumbing. So that means holes are cut, or any type of openings that allow you to put wiring through. The same, instead of having a drill like you do floor joists or studs, you have those openings there. They're pretty handy. And floor joists should be positioned so the openings are at least 12 inches from any bearing points. And the outer ends of the joists are attached by metal angles to a rim track that serves the same purpose as a header joist in a wood frame construction. Here, the main components of a metal frame floor are shown, and they are the joists, the rim track, the cross bridging, and blocking. These ensure framing components are installed in the same direction so that cutouts align to allow for easy installation in utilities. And as you can see there, keeping all those cutouts in a row is an important thing. If you're running a straight pipe through this, you can't have those cutouts jogging to the left and right. The same goes for the steel studs when in a wall situation. So in this figure, it shows a framed floor unit over a full basement foundation, and the rim track is directly fastened to the foundation, as we were talking about previously, with clip angles. One part of the clip angle is secured to the foundation wall using an anchor bolt, and the other part is secured to the rim track with screws. Bearing stiffeners tie together the ends of the joists and the rim track. In hurricane and seismic areas, hold downs may be required to tie down the wall studs and track together and fasten the assembly to the foundation. The floor opening for a stairway is framed with headers tied to trimmer joists, and you can see this here in the figure. A trimmer joist is constructed by fitting a C-shaped joist member inside a track member of equal size and securing the two members together with number 8 screws, sometimes 24 inches on center, sometimes 16 inches on center, and clip angles tie the headers to the floor joists. So this is what's called inline framing or stacking. It's used for light gauge steel construction. Inline framing requires that all joists, studs, and roof rafters are in a direct line with each other. This is a lot like wood construction, where the floor joists have to fall over a stud. A maximum variance of 3/4 inches on either side of the center line is allowed, however, and unlike the double top plates of a wood frame building, the horizontal tracks of a metal frame wall cannot adequately support weight between the spans of the studs of the joists. So the metal framing is often lightweight enough that it's not meant to carry any type of a joist if it was off of the stud to the left or right, or any more than that 3/4 inch amount is exactly what's happening there. So top and bottom tracks are comparable to the top and bottom plates of wood frame construction, and the tracks consist of a web and 2 flanges. The web width of a track must be equal to the web width of the studs. Track flanges may be bent slightly inward to ensure a tight fit between the track and the studs. The studs are placed at an angle between the track flanges and turned so they are perpendicular to the track. Anchor bolts are commonly used to secure the bottom tracks of a load-bearing exterior walls to concrete slabs or foundations. Bottom tracks must be reinforced with a washer, hold-down bracket, or plate to ensure a proper connection. they're just simply too thin, and if you were to use, in the old days, we even used a shot, the powder type actuated fasteners. The thing is that a little bit upward force, and they just rip right through that metal bottom track, and that's the reason for putting a washer as well. So anchor strips and mushroom spikes may also be used to secure the bottom tracks and positions. Powder actuated fasteners now should not be used to permanently anchor bottom plates to slabs or foundation walls, so that's pretty much out. A first floor exterior wall placed over the floor joist, the subfloor, is shown in this figure. Note the inline framing of the studs directly above the joists. The wall includes a window opening with a header, sill plate, and top and bottom window cripple studs. Diagonal braces or tension straps are used to brace studs against lateral movement. An outside corner post and stud to track connections are identified there. Exterior walls are sheathed with APA rated structural panels, OSB, or plywood. So similar to wood frame construction, headers are installed above wall openings in exterior walls and interior load-bearing walls. Headers are formed with two equal-sized C-shaped framing members, and what you do is make a box beam header or a back-to-back header, and may be constructed with one or two angle pieces that fit over the top track. That would be an L header in that case. You can see in the different drawings here what a box beam looks like. The back-to-back header kind of forms an I-beam, and the L header with the track over the top of over the top and bottom there. It's a little bit different. So an inside corner post is required for proper attachment of interior wall finish material. If you don't have something in the corner, you won't be, for the drywall you'd have to put in what's called a floating stud, let's say, and you need something to catch the drywall. So an interior corner post can be constructed in several ways, of course. It's different in metal framing than wood framing. This figure shows two methods for constructing inside corner posts. Where a non-load-bearing wall intersects with a load-bearing wall, that's one type altogether. There, a 6-inch or larger stud can be installed in the exterior wall, and the smaller stud is fastened back-to-back with the larger stud. And another method, similar to constructing inside corners for wood frame buildings, involves fastening two equal-sized studs back-to-back. So either of these applications are acceptable. Wall studs can be pre-cut to the proper length and delivered to the job site, or they can be cut on the job site with a chop saw. The walls are framed on the subfloor or a separate panel table. A common wall framing procedure is as follows. Lay out the walls on the subfloor or panel table in snap lines. Cut the bottom and top tracks where it is necessary to splice the tracks. Insert a short piece of stud material and fasten to the tracks as shown in the figure here. Position the tracks on edge next to each other and use a black felt tip marker to lay out the studs, usually 24 inches or 16 inches on center, and mark the tracks using standard conventions. So a common problem for raising and placing walls are as follows. To measure the measurements of the locations of foundation anchor bolts, which you have to transfer the measurements to the bottom tracks and drill holes so the tracks fit over the bolts. Here you can see the other problem is just simply raising the wall into position and then placing it over the anchor bolts. Here you should attach braces to the ends of the walls, about every 8 foot to 12 foot between the ends. Studs about 12 foot long work pretty well for braces. That's an angled brace that goes to the subfloor there, if it's a wooden floor, to the wall itself at the top near the headers. And nail wood blocks to the surface subfloor, of course, in a wooden situation. That's a good way to do it for the subfloor. The concrete ones, we usually used to use the powder actuated tool, or else you could just bolt them down with an expanding bolt. You want to make sure the powder actuated tool can be a little iffy since a little bit of high winds and they will rip out. So you want to make sure the walls are anchored pretty well. Obviously, you don't want the walls toppling over due to some wind. Here you can see a continuous strap beneath the joists, there on the lower left of the drawing, and that's bridging, and it should be about 12 feet on centers and attached to the ceiling joists from the underneath. It provides rigidity. What it does is it helps all those joists from flopping over, kind of like a block of dominoes. So ceiling joists are placed after the walls below have been plumbed, aligned, and braced. And for a multi-story building, the ceiling joists also serve, obviously, as floor joists. The framing procedure, fasteners, and components are the same as those used for first floor joists. Ceiling joist bracing is fastened to the bottom of the joist where spans exceed 12'0". And here, ceiling joists must be placed directly above and in line with the studs below again. When joists are lapped over an interior load-bearing wall, the first floor wall studs will be directly under one of the lapped ends. Take a look here in the figure. A bearing stiffener is used to secure the lapped ends in position. And for continuous span joints supported by a load-bearing wall, at the midpoint are used. The stud should be placed directly underneath again. Where walls below run parallel with the ceiling joists, blocking is placed between the joists at a minimum of 48 inches on center to provide anchorage for fastening the top of the walls to the ceiling. So see, here you are running a wall where you really would have an open space, and quite often that bridging is just a flattened out, one of the flattened out C channels made on site there. You just do it with a hammer, or you just flatten the ends where you're pretty much screwing it to the joist. It leaves a little bit of rigidity to this type of bracing or blocking. Remember, blocking is just like in wood. It's fabricated on site, made from scraps. Same idea in metal framing, but this is how it's done in this type of a situation, as far as attaching the top wall, the top track to something. So for rafters, if covering long spans, rafter support braces extend from the ceiling joist to each of the rafters, and where those are installed, as in figure 4533 here. And rafter support braces are typically 2x4s by 33C mill-shaped members, which are fastened to each ceiling joist and rafter with 4 number 10 screws at each end. And the rafter support braces and rafters are stiffened by lateral braces. Lateral support braces for rafter support bracing are C-shaped or track members, spaced 4 foot on center. Lateral support braces for rafters are fastened to the bottom flange of the rafters and could be flat strips, C-shaped members, or track members. So metal roof trusses are frequently used to construct roofs over metal frame buildings, and you can see that here. The design shapes and engineering principles of metal roofs are also similar to wood trusses. And the temporary and permanent bracing methods for metal trusses are as well similar, so that while you're putting up the trusses to keep them in place, keep them from being knocked over by the wind, that's where you put all that temporary bracing. And if you want to look at the truss methods, it's harder to find how to place it for metal studs, but you could use the wooden truss placement guides as a rule of thumb. So metal roof trusses can be constructed on the job site, of course, but mostly the trusses are prefabricated in a shop. Same as the wooden trusses. It makes it easier, saves work on the job site. They're done here in jigs and templates where they'll come out almost perfect, each one to the other. So the trusses they're constructed here on a level surface, such as the shop floor, subfloor, tables, as here in these elevated jigs. And manufacturers design the entire roof structure and furnish shop drawings and specifications to a general contractor. They're working as a separate unit, kind of like how you get your windows and doors. That you obviously don't fabricate much of that on the site anymore. So it comes as a component already done for you. So here's some seismic and hurricane strips that should be used with metal rafters and trusses, obviously in areas prone to earthquakes and severe winds. Most codes are showing that you have to have these in all areas. So this figure shows the metal connectors that are used to tie metal framing walls to framed roofs. And again, they look a lot like the wooden type, the hurricane straps. They're just a twisted strap so you can connect in both directions. So structural steel framing is on the increase for residential and light commercial buildings. You see it going up all over. And it's also referred to as red iron steel framing because of the characteristic color of the framing members. That's because of the primer that's placed on them. They involve the use of a bolted or welded connectors to form the framework of a structure. And the framing members are painted with that durable red oxide, that's the primer, that resists corrosion. And after the manufacturer, he is spec'd usually to do that. It's part of a lot of the codes that these metals have to be pre-primed before arriving to a job site. So the use of structural steel framing, of course, is even increasing in residential and light commercial buildings up to only 2 stories in height. So you're beginning to see steel members like this used in residential as well. And depending on the type, size or the type of the framing members, structural steel framing members may be joined on the ground or at the job site and erected using a crane, or the framing components may be erected individually and joined together. The assemblies or individual structural steel framing members are erected using a crane or other hoisting equipment because of their weight, obviously. They weigh a lot more than the light gauge steel we were looking at previously. And columns are fastened to the foundation or concrete slab using anchor bolts. This is all anchor bolt type work. The assemblies and individual framing members are joined using bolts or welding on site. So they can either be bolted in place, like on the left, or they could be welded as well in that same situation. So due to the size of structural steel framing members, large open spaces can now be created within a building, offering a greater flexibility in room layout. Structural steel framing members are commonly spaced 8 foot 0 inches on center, and heavy gauge steel framing members placed 16 inches to 24 inches are used to fill in the spaces between the structural steel members, as you see here in the figure. So windows and door openings are framed with wood or heavy gauge steel framing members. A lot of times the wood is there to make it easy to receive the window to screw into the wood. Seems to make a better type of subframe, or and just a subsurface to adhere to that's a lot easier. So here we see oriented strand board. This is placed on the metal studs, same as wood studs, and the screws of the drive pins are installed 3/8 inches from the panel edge and typically spaced 6 inches along the edge and 12 inches on center at intermediate studs. You can find that right in the code books as far as all of the fastener schedules. These are important to follow because they add support to the structure. They're really critical in the metal framing, which tends to be a little bit more flimsy than wood framing, of course. So another thing is this will give you that increased strength, and it's obtained by also applying a continuous bead of construction adhesive along the studs and rafters before fastening the panels in place, just to give a little bit more strength to the whole item here, to the whole assembly. So when masonry is used in exterior finish, wall ties are fastened for the studs, and they're embedded between the masonry courses. And several wall tie designs now are available. That's another thing that we'll look at in masonry modules and learning modules on masonry. But just to give an idea, they can be attached to the metal studs as well. So finally we're getting down to the end here, where you see the exterior finish and exterior insulation and finish systems are common as exterior finish on metal frame buildings, obviously. And one of the biggest advantages of using an EIFS, we'll call it, exterior insulation and finish system, with metal frame building is the elimination of cold bridging. And cold bridging occurs when construction components, usually structural members of a door or window frames, have greater thermal conductivity than the rest of the building. and they extend from the interior face to the exterior face of the building. So think of that as the interior face of the window and the exterior face of the window frame, both sides of the frame, and that's called a thermal bridge. But since our structural members do not extend across the faces, cold bridging in EIFS construction is eliminated because you have this continuous foam running across. In addition, there are no fasteners to contact with the exterior to even those even transfer the cold to the interior of the building. So this is it also makes a very good insulation type system by using these metal studs and having this type of exterior sheathing with a rigid foam insulation board over it. And insulation for metal steel frame buildings can be, again, the rigid foam or fiberglass blankets that are placed, or even a combination of the both. And mostly today, to achieve the new recommendations for insulation, especially in energy efficient areas, especially like that in Florida, where you were going to have to use cavity insulation in exterior anyway. So the outside type of cladded insulation, a foam board over your structural panel, because the numbers are odd. The numbers are more like for achieving R20 and R21 instead of R19 for walls, let's say. You can't go out and buy R21, that would fill the cavity, so you're pretty much stuck with having to put something of an R2 value outside the building area, and that's why they've done that, and that also helps provide for that continuous insulation. So that's the idea. And with that exterior bit there, we're going to conclude the presentation here on metal building. Thank you.